Uh,
Good afternoon to all present here. It gives me immense pleasure to welcome you all to the 27th talk of Transpedia Research Talk Series organized by NATPAC. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here we will be featuring eminent young researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today we have with us Dr. Vishwajeet Verma, research scientist at Department of Civil Engineering, IIT Bombay, for sharing his valuable insights on the topic, the performance evaluation of public transport systems, the ongoing approach and way forward. Now I request Karen Chandran, Senior Scientist, to deliver the welcome address.
Thank you, Siddhi. KSCSTE-NATPAC has launched a technical discussion series called Transpedia Talk series, which is envisioned to promote research for shared benefit by disseminating knowledge on diverse topics from cutting-edge technologies to sustainable solutions. Desirably, this also brings out a platform for the young researchers across the globe to connect and interact to better shape the future of research and development in transportation. The inaugural talk of the series was conducted on 24th August 2023 in an online platform, and the inaugural address was given by Professor Tom B. Matthew, Chairman of the Research Council KSCSTE-NATPAC and Professor IIT Bombay. The 27th talk in the series will be delivered by Dr. Vishwajeet Verma, Research Scientist in Transportation System Engineering at the Department of Civil Engineering, Indian Institute of Technology, Bombay. It is with great pleasure to extend a warm welcome to our distinguished speaker, who has graciously accepted our invitation to share insight and knowledge on the topic performance evaluation of public transport system, the ongoing approaches and way forward. After the presentation, we will have a question and answer session where you can pose your question and engage in a meaningful discussion with Dr. Vishwajeet Verma. Feel free to participate actively, and thank you. Over to Ashwati.
Thank you, sir, for the welcome note. Now, I would like to invite Dr. Vasudevan, Junior Scientist, to introduce the speaker to the audience.
Good afternoon, everyone. Today, we have Dr. Vishwajeet Verma, Research Scientist in Transportation System Engineering at the Department of Civil Engineering, Indian Institute of Technology, Bombay. He earned his PhD in Transportation Engineering from IIT Roorkee and holds an MTech in Transportation Engineering from NIT Karnataka, Surathkal. In addition to his academic journey, he has 1.5 years of post-master's industry experience. He also worked as an independent research consultant supporting organizations in advancing sustainable transportation and gender equity focused industrial research projects. His research interests include transportation planning, public transport, survey methodology design, decision analysis, market segmentation, data science, and machine learning. With this note, I welcome Dr. Vishwajeet Verma to this talk series.
प्रॉब्लम हो गई है लग रहा है, अब नहीं हो रहा।
Now, I invite our distinguished speaker to deliver the talk. Over to you, sir.
Okay. First of all, many thanks to NATPAC and team. This is a great initiative that you, the whole team members are collectively doing to bring all the young researchers like me and deliver the informations to everyone. And I thank for this great introduction that you have given. So without taking much time, so I'll just start my presentation. So I'll share my screen. Okay. So is my screen visible to you all?
Yes, yes.
Okay. So so I'll be speaking on this performance evaluation of public transport system. And so when we will first look at this, what are the available, the ongoing approaches so far we have across the globe and including in India. And then we'll look at it, what are the shortfalls or limitations that are being observed in those approaches, and how we can come forward to limit those limitations, and how we can do performance simulation of public transport system, which we'll be talking in this way forward. There, thereafter, we'll have a kind of case studies where we will see how this the methodology can be adopted, and how we can quantify this public transport system performance with respect to a overall comprehensive framework. So with that context, I'll just start the presentation. So if we look at this public transportation, so it is generally accepted as like it satisfy the sustainable transportation's option, wherein the social, economical, and environmental aspects are being dealt in a sustainable way. So however, if you look at this, the public transportation system, so it has certain inherent characteristics due to which the due to which the dynamic travel demand scenario in a say city with combining with this land use and trip activities are being affected. And due to this inherent characteristics of like fixed origin destination routes and dedicated time intervals, frequency and all, so these all create an issue that causes fall in right share. So these all are like interconnected with those things. So then the issue is, if we want to improve the any public transport system, so how we can improve. So in general, it is accepted that if you want to improve any system or anything, so we need to first measure how it is performing, and the performance should be measured in certain aspect, and check which aspect it is performing good, or which aspect it is performing low, so that we can identify the critical issues, and then we can address by solving those issues. So in the same way, so the transit performance evaluation provides us in a effective and efficient, like it provides a solution to the effective and efficient public transportation solution. And the major objective of this performance evaluation is to improve the quality of service, so that the more consumer can be benefited, enhance the ridership in long terms, and stand competitive against other transport alternatives. And as I said, the ability to improve transit performance relies to a great extent on the ability to measure it. So then, which are the applications of this transit performance evaluation? So it can be used to monitor how this transit service is delivered to the passengers, how it was last year or say in previous time, and how it is going to be delivered in the next future. And then economic evaluation, like how much investment has been made to this system to improve it, whether it is going to deliver in a meaningful service quality or performance to the passengers. So this economic evaluation can also be done. Then again, we can use this evaluation to improve the service design standards, to like benchmarking public transport system, so that we can use as a guidelines to the other rest of this city level transit system. And then we can also use to as uh, uh, communicate the achievement, if say like any public transport is able to achieve this many ridership in so and so year, so this can be used to communicate how much benefits, how much profits, revenue they have generated, so and so. And then in the last, like we can also estimate how this community benefits are being by how this community benefits are being delivered by using this evaluation measures. So these are the need of this transit performance evaluation. So when we need to do this evaluation, so then the question is which are the measures or approaches that we have available with us. So the literature says there are 5 evaluation measures. So the first one is efficiency and effectiveness, which is the output upon input that we generally use to calculate the efficiency and effectiveness. So it is mainly deals with this transit operation related characteristics performance. Then we have second, which is based on user perception, and wherein we use the importance and satisfaction levels attributes uh, 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 to the service quality attributes of a transit system. Then third one is the combination of both efficiency and effectiveness and the user perception. So wherein this was more related to this quantitative characteristics, and this is related to the qualitative characteristics. When we combine these two, so then we can uh, assess performance of transit system by combining these two aspects. Then fourth is related to the level of service, wherein we look at this how this level of service is being delivered or is available as of now. So maybe in terms of A, B, C, D, E kind of, wherein A will be the excellent and E would be the worst service quality level. Then next is related to how this approach, this combination of user and operational, as well as how the transit system affect to the community in terms of like how much externalities is generated with respect to the noise, air emission, and how much land use they are taking and not being used as in resources to operate this system. So with this 5 transit system, when we understand these 5, and let's say if this is the dotted rectangle is a system wherein the input is let's say the labor force, capital, infrastructure, and so, and these are used as in transit agency, of which the services are being generated in terms of let's say vehicle per routes, vehicle kilometers that they generate, passenger kilometers that they travels, route kilometer per vehicle also, like how much they travel. And then again this is the services that are being generated from this transit agency. If we look at from this user perspective, so that is the psychological understanding of a user. So we quantify, as a user, we quantify the psychological aspect in terms of ease, comfort, convenience, and so and so. So this is all about a transit system. So if we can take input and output and take a ratio of these two, this will give us the efficiency that we talked in the previous slides. And if you look at this, the output, how much output is generated out of this overall transit agency, so that is effectiveness. So that is being considered in this first aspect. In the second aspect, as a passengers, so there is a system impact, the impact from the system from this transit agency, and there is a service quality that is being delivered. So as a passengers, there are certain aspects that are important to us, that is considered in importance, and how much we are satisfied with respect to those aspects, that is the satisfaction level from the passengers. So these all will be quantified for this service quality that is being generated, as in for this psychological point of view. So this all is a perception based from the user point of view. So these all deals in perception. The second category. The third category, that is the combination of these two when we have, so we'll get a clear idea of overall assessment of transit system. Then if you can quantify in terms of LOS, like A, B, C, D, E for this effectiveness as well as for perception. So that is a level of service quantification. So with these things that we can understand, these are all TPE measures that we have seen in the previous that 5 measures. All of these are interconnected, and if we look at this, so each measures that we have deals separate decision context. So let's say if we are looking into the transit system administration and logistic aspect of a transit system, so then we can apply these measures. In a similar way, if you are looking at this transit user related services, transit system operation, and how this system inbuilt travel utilities are being provided, so we can apply this service quality based performance measures. Similarly, we have LOS, so then we can apply this, quantify this in terms of A, B, C, D, E. So LOS for this particular decision context. In user and operational, so we can have this user related services as well as so for assessing performance for user related services, we can apply this user and operational and other aspects. Similarly, for this community related, so we can, if we are interested in this route and network management, so then we can apply this community related based measures and other as decision context. So, but interestingly, if we look at this all measures, so there is no not a single measures which deal all these decision contexts, and that is the limitations of each measures that can be observed from this slide. And so the question is, okay, so after this, let's talk about this India. What are the measures approaches that we have been using in Indian context? So here, if you look at this, there are all state road transport undertakings, so which are around 54 in the country. So which particularly use revenue cost structures and indicates what are the net profits losses that they are making, and based on those information, it determines the operational efficiency by using this physical and operational parameters. So this is more or less about this efficiency metrics that this state road transport undertakings are using. And out of all those 54 state road transport undertakings, so they annually release these reports, and they so that which are the SRTU is performing best and which are the SRTU is performing worst, and then they also have a best practice manual. But this is all about this efficiency parameter. Now next we have this urban transport service quality service level benchmarking that we say, that is being presented by Institute of Urban Transport. So wherein what we do is that we estimate the service quality as a whole city level. So wherein we include this pedestrian, paratransit like e-rickshaw, auto rickshaw and all, and then public transport altogether. So let's say if we are interested only in public transport, so it is very difficult to quantify, and then aspects are very little in this benchmarking scheme, benchmarking service level benchmarking method that is being presented. And then if we look at this DMRC, Delhi Metro Rail Transport Corporation, so they conduct service quality feedback survey of LD. So the last one, they have conducted in March 22, in August 22. So they have been using a different feedback survey. So each time they have different level of aspects that they conduct. So in the 9th edition, they have used this questionnaire that is from this Transport Strategy Center, London, and that is from this Comet benchmarking group. So when we have different questionnaire for feedback survey, so comparing performance or service quality from one year to the previous year or to the next year, so that we can indicate how good we are going ahead with this. So time-based year-based performance is difficult in this case, since the attributes are different and approach are the questionnaire in itself is different. Then we have guidelines in Indian context, so that is IRC 124/2017 that lists the evaluation criteria, and it specifically talks about this DRT, and that is also related to this operation based variable. So then recently we have developed this IRC 131/2020, and that is for the sustainability evaluation of non-motorized transport. So these are the approaches that are being used in Indian context. However, a comprehensive picture of assessing transit performance is missing in these all approaches so far. So the if we are able to summarize how this transit performance evaluation has to be are being conducted globally, so then we have goals in our mind, like if we want to do operational level performance assessment, so or we want to do a service quality based assessment, or we want to combine, or we want to go for LOS or overall performance. So based on the goals, the level of analysis also gets different. So if you are interested only at this one system level, or at the one particular route itself, or in the agency, say like whole DMRC, that they have different metro service operating in different city. So then how DMRC is performing with respect to say Mumbai metro rail and something. So the level of analysis, then next level is to identify, and based on then we can identify which evaluation method we need to adopt. So these five that we have talked, so based on this requirement, goal of this performance evaluation, we can choose, and then each evaluation method has certain aspects, so those need to be identified, that we call influencing variables. So it will be different for each method, and then how we are going to analyze those information for each variable. So it may be for the score estimation, or assigning rank to each transit system or routes in terms of like ascending or descending order, or we are interested in a composite performance index, which will talk like, okay, this index is around 7 out of 10 performance given to say Pune Metro or something kind of. So then based on this performance assessment, we can improvise by identifying which are the inefficient factors or parameters that is going to be that are going to be looked upon, and accordingly the subsidy allocations and all like concentrations of this efforts can be improvised. So that is how we call it 5-stage approach for this transit performance evaluation. And if we can further continue to understand, as we have seen in previous, this all 5 measures overlaps among each other. And then question is, which parameters should be identified for which type of measures? And then there are the certain limitations in Indian perspective that we have seen. And next is there are certain stakeholders that are involved in overall, like in operating, in planning, in designing, and in policy making. So those stakeholders perspectives has to be incorporated in the when we are assessing the transit system performance. And of course, since it deals in large amount of data, so it is a data centric approach. So this is all about this summary of transit performance evaluation. Now next question is, we had understood what are the limitations and so far. So how we can have a transit performance evaluation approach which shall be a comprehensive in sense it shall assess the operational service quality from these passengers and this impact that they are going to uh, make in the community or in the overall environment. So can we have a something, a comprehensive transit performance evaluation? And if we have, so which approach shall we need to use, and how we can begin this analysis. So for that way forward, so and then the challenge is, if we have a, let's say, that method, then we have a family of different transit systems. So this straight transit is belongs to this part of, like when we plot in line capacity and operating speed. Then we have semi-rapid transit in belongs to this in middle of this, like it is going diagonally. So then we have rapid transit. So if the framework that is being prepared can be applied to all form of transit system that we have available from this family of transit system, that is the question. So to understand that, let's see how this transit system works so effectively. So if we look at this, there is a transit route network, there are infrastructure and the services that they produce, and then the impact they make to the environment in terms of noise, air pollution that we have explained. And there are stakeholders, let's say advisory, who advises of advises to how to run the service system. Then there are policy makers who makes like so and so transit performance has to be delivered, like this has to be made for this economic understanding of the city for the passengers and all. Then we have service operator and service provider, which sometimes interchangeably being used. And then we have passengers whose satisfaction to the service quality and route networks and all determine how they are going to, whether they are going to use the service or not. Then we have community representatives across all these this that affect this transit system. So this is typically a kind of indication, graphical indication of how a transit system performance works. Now this looks complicated when we can combine all this, the flow of interaction, and then we can get something sort of like how these resources are being utilized and externalities are minimized to make a societal to make a the system beneficial for the society, and how the society is going to react by consuming the services by that is being produced by utilizing a system infrastructure and all. So this is all, and again these services that are being consumed is majorly based on this passenger satisfaction and loyalty to the transit system. So now we have, if you can see, there are 6 component that is being divided, and if you can understand, this is resource utilized and externalities. So these resources utilized, services produced and consumed, and the system infrastructure, these all can be combined, and based on this, how we can apply these transit performance approaches that will give an overall and comprehensive assessment. To do so, what we have thought of is a framework that is CATP, that is Comprehensive and Inclusive Transit Performance Evaluation Index, and that is framework. So what we have done is that we have developed a comprehensive, inclusive, and flexible TP methodology. So, and it also considers this passengers and various stakeholders perspective. And if you can look at this, so this will be something here which has 3 components. So one component will deal all operational performance. So operational performance, that is the operational characteristics that is taken from these 3 indicators. And then there are system infrastructure. So how that is going to be, those aspects are measured through physical infrastructure index that directly or indirectly supports this operational performance. Then second is the service quality performance that is collected from this passenger perception with respect to these aspects collected through importance as well as this quality, and that is estimated in terms of service quality index. Then third component is that is the community and equitable infrastructure performance. So how the system is universally accessible to all forms of all types of passengers whether they are person with disability or elderly or children or pregnant ladies or who is having difficulty in accessing. So these aspect universal accessibility will be measured at a station and when you enter to the system while onboarding vehicle. Then we have externalities in this, wherein air emission and noise emissions are being addressed. So the basic understanding is that if we can assess operational from passengers and this impact to the system by using these three components separately, so this will give a comprehensive idea, like comprehensive aspect of this performance assessment, as well as if we are interested only in this passengers form of performance assessment, so we can focus only on this part and ignore the rest too. Or let's say we are interested in operational as well as passengers performance based perception based performance, so we can include these two and ignore these three, or if you are interested in any of. So this kind of flexibility will be provided if we are using this framework. So what we have done is actually, okay, so then for this framework, what are the forms of data that will be required? So there will be two forms of data. That is primary survey that may be collected from this expert survey for stakeholders opinion and all. Then from passenger importance survey and passenger satisfaction survey. Then second form of data is secondary information, because we need to know this average daily ridership, fleet information, route information, and this like how many vehicle kilometers they travel in a day, this noise level inside this vehicle, outside of this environment, how much electricity they consume, they are using electric vehicle and all. This kind of information will be required to use that CATP framework. And so what we have done is we had selected four different transit system from three different Indian cities. So, and those four transit system are selected in such a way that they belongs to a family of transit system that we have seen in the previous slides, and it includes from the lower transit system to the upper transit system performance family of transit system. So first is that if you can see, this is BRTS from Ahmedabad that is being taken up. Then second is DTC bus from New Delhi. So then this is next is from this DMRC Delhi Metro from New Delhi, and then last is from this suburban rail from Mumbai. So all these four will makes like DTC in the lower transit family category, street transit, and then we have DMRC in the rapid transit system. Meanwhile, we have Ahmedabad BRT in the middle of in between these two, and suburban rail is somewhere it belongs to this DMRC. So we then selected these four transit system, of which if we can see these details related to this, how this number of stations, terminals, fleet size, average daily ridership, and average trip length, their references are there from where it has been conducted. So then this CATP framework was applied, and if you can see this operational index, there are three indicators. So, and this formula that we have been used to put those values and estimate the performance for each transit system. So CBT, city-based transit, BRT, MRT, suburban rail. And these, if you can see the ranges, it is 0 to 10, 0 to 10. So that anywhere at any point, if we are interested only in one form of performance indicator, so we can only focus on those things, and we can, when we can sum up all these things, like there are 12 of these indicators, so when we sum up, so we'll get around 0 to 120 range. So, and then that will indicates provide the flexibility of choosing or selecting or removing this indicator for the CATP score that we have talked about. So, and Zero indicates like the lower the value, the lower the performance. Wherein if you move upward, higher towards the 10 score, the higher the performance. So in all these indicators, formula are designed in such a way that it takes all these meanings from this. So if you can see here, let's take about this example of perceived travel time reliability. And if you look at this for this BRT CBT, it is coming around 6.41, and it is for BRT it is coming 5.23. For MRT and suburban rail it is coming 9.53 and 9.23. So this indicates that this MRT and suburban rail have dedicated railway track and corridors, so there is less interruptions of this other traffic interaction, due to which this travel time reliability is able to get higher in this case. Whereas in this BRT, and this BRT is from Ahmedabad, so why this is why it has got 5 is because in Ahmedabad, so the corridor, BRT corridor is not like overall I mean throughout the corridor is not separated. So at intersections, it has to wait, and other traffics are allowed to pass. I mean, it behaves like a normal traffic. Due to that, the reliability score got reduced here. Then if you can see here in terms of unit travel time inside system, so this indicates like how much travel time a passenger is spent when they enter to the transit system. So then again, if you see this BRT, it has lesser frequency as of now. In Ahmedabad it has got 3.61, whereas in CBT it is 5 because of high frequency available, sorry, this from the like at the moment you stand at the bus stop, so you get the bus service there itself. So there is no time to get, I mean there is no time spent to get that, buy the ticket, move around the system, and then so due to that it has received 5 score. Whereas if we look at this MRT and suburban rail, since uh, it has higher speed of travel speed of this vehicle, and you can use this service, so it drops you to your destination very faster than compared to CBT, which is having around 18 kmph average speed in Delhi. But in MRT and suburban rail, something around 33 or 35 kmph speed is achieved. So this is MRT. This has got this unit travel time inside system. So likewise, we have, if you can see here, GHG emission index. So there in greenhouse house gases emission. So this index calculates for this CBT. If we take, it is 0.44, and this is the data that is being used is all this vehicle are diesel or CNG based vehicle. As compared to BRT, if you look at this, this is performing better because this in Ahmedabad they have recently started using electric vehicle, and for electric vehicle the emission factor is because is calculated on the basis of how much time it takes to recharge the battery and how much time it can travel. So the electricity required to charge a battery for that particular travel for single charge travel. So that is being is used to estimate this BRT. So the electricity, when the electricity is used, so that electricity at the power plant electricity generation grid point itself, it generates some emission. So that is being used, and which is less as compared to this CBT from this Delhi in this BRT. In similarly in this MRT and suburban rail, they also use electricity to run this vehicle, and which is found that suburban rail performs better than all other transit system. So then we have this universal accessibility. If you can see suburban rail, like in Mumbai, because of the unavailability of data that need to go aside and collect this. So at this moment, it is 0, 0. And but for MRT, if you see, it is designed to consider this physically disabled people and all this ramp escalators and this tactile pavers are being marked and all. So based on this, this is being assigned this attestation and on board. So this 10 out of 10 that is being given. Whereas in this CBT and BRT, 4, 4 and 6 2 are given. So likewise, we can do and apply this framework to any transit system that are being shown on that are being seen here. How which different kind of transit system that we can apply this framework. So that is all. And then how, if suppose we want to see whether this CBT or like which aspect is performing low or higher, so then we can apply this performance appraisal schemes, which is nothing but just divide the 0 to 2 range into 5 category, where a 0 to 2 will indicate non-functioning and 8 to 10 will indicate this exceptional performance. And then we can see which indicator belongs to which category of this transit system, and then we can improve the corresponding weak area. So this is a way out of doing the using the CATP framework in any of the transit system that we can do. So that's all from my side. So if you have any question or all, so you can ask. I think. Yeah.
Thank you, sir. That was presentation. Now the forum is open for discussion.
Okay. So anyone have any questions can ask or can send this query later to me. I may respond.
Okay. Yeah, I'm Dr. Vishwajeet. This is Vasudevan.
Yeah. Yeah.
It's a nice presentation. So I have two queries regarding the development of that framework. How you have considered the first mile, last mile connectivity and the accessibility issues,
Okay.
and how it was measured exactly.
Okay.
And
So the
secondly,
okay.
and the second question is the service quality index. I think that in that result slide, the service quality index which was mentioned has some kind of which has I think BRT is better, it shows, rather than metro.
Service quality index here BRT 6 it has came.
No, I think
Is this
MRT. I think that metro is better
okay?
compared to other. Is it like that?
Yeah.
Or-
Yeah. Metro is 6.39.
Okay,
Okay.
almost more or less all are similar. This is how it is
Yeah.
explained.
Actually, in this service quality index, there are certain indicators actually. So to look at why this has got this, so we need to go into like which company this aspect has received higher or lower. So for this is just a final result actually. So when we go into detail, so there are certain aspects which I have not shown here in this slide because of this time limitations, and this is like my PhD work that I have done, and it is under consideration of publication as well. So anyway,
Mhm.
yeah,
And
yeah,
yeah, and here also that noise emission index is also higher in BRT, and
yeah, in
higher value means
BRT,
safer for human ear. That's what my
yeah,
confusion.
okay. So this 0 to 10 range is 10. The more the value, the safer it is for human ear. That is interpreted as. So the BRT has received 6.25. So actually, what we have done is So we need to do this survey, like we need to go to the to the transit system and conduct survey. So this was we had taken as at a random, like so there are certain provision also as per this standard of how this like if it is a bus, so what is the standard allowable, if we'll say allowable noise in decimal. So that is given from this ministry itself. So we have used this, and 30 to 120 range is as a human ear that we can, 30 is the faint decibel noise, and 120 is the something of jet or a firecracker bursting nearby our eardrum, and that may cause to eardrum rupture. So for the safe side, what we have selected, we selected 100 as a safe side, and the minimum is 30. So and then, so 30 we cannot take it, because this we already have information available from this ministry, that which is what is the limit of this available noise inside the vehicle. I think that is something 65, as if I can remember. And then this is this actual actual that is being observed on field. So based on this proportion and all, so then we can get this BRT is uh, assumed to be higher. But in
Okay, so it
MRT,
has both.
yeah,
I think it has both questionnaire survey data as well as the sensor received data, or purely questionnaire survey data
okay. So
used
this
for
is
this
not
analysis.
from the questionnaire. This is from this inventory data. Like we have to go to site and then select some random routes, and then at random time, and then we have to collect this through noise noisometer, and then we can feed those value here, and then we can get it here. So for the BRT, we
Okay.
have taken hypothetical, like all this for this all transit system, we have taken hypothetical value, say 80, 85, 100 sometime also. So and then we have got this. This is not this actual result. This is based on hypothetical value how it will behave. So
Okay. Okay. Understood. And regarding first mile, last mile connectivity, the-
yeah, first and last mile connectivity, if you will see here, access egress utility with respect to the catchment area. So what we are doing is, if you can see here, this is CR is catchment area, and this is mean of access egress. So we have asked from passengers, like what is like how far they go from this when they take, I mean origin and destination, sorry, alighting and access and egress distance from this nearest bus stop to their destination or origin. So when we ask this information, and then we take mean of these two, so arithmetic mean of these two are taken, and this is something, this catchment radius is estimated based on this total route length divided by this number of stations or bus stop that is there. So each stop will have certain catchment radius. So this, when we take this ratio, so if suppose mean access egress is similar to same of catchment radius, so that means the access egress is on the catchment radius, that is 1. So we have taken negative exponential. So as you are coming near to this bus stop or station, your score will increase. As you are going further away from this catchment radius, so your score will reduce. So understanding that concept, we have taken this value, and then of all the survey, we are taking 85th percentile of the total value. So that will indicate that 85% of these passengers are having how far or near they are to the bus stop or station. So utilizing that concept, we have used this access egress utility in this estimation.
Okay, thank you.
Okay, so hope I am able to answer your query. So this is just like, we apply this framework and see how good or bad the system is performing. So this is like uh, by the use of this score only, we are just assessing how good or bad the system is. So this value is not like all this city bus will have 1.5. This is specifically for this Delhi bus system that is getting 1.58. So if we are applying the same methodology to another city bus or across India, or so we will get a different score. So then we can say, okay, whether if the other city buses are also getting, I mean, how good or bad they are in terms of this first or last mile connectivity. So kind of we can do the comparison as well.
Okay, understood. Yeah. And Joshi sir, good afternoon. Sir, are you?
Good afternoon. I listened to Dr. Vishwajeet, very comprehensive study. I really appreciate it. But I have one query. When we compare the scores of the city bus systems, BRT, MRT, and suburban rail, then you already had shown in your presentation the operating characteristic thresholds or the ranges are different for this city bus, BRT, as well as MRT. So in
Yeah.
that case, how these scores become comparable?
Okay, so yeah, it's a good question actually. So since the functions are designed in such a way that all of these indicators are in the range of 0 to 10 itself. So when the range is same, so then whatever the values that it is getting, so 5.39, it is out of 10. And in the same way 3.61 is out of 10. So all these values are out of 10 scale, so they are on 10 scale. So now if we are able to compare, okay, BRT on this particular unit travel time aspect of this Ahmedabad is getting 3.61, so then CBT is 5.39, which is having higher score because it is designed also that higher the value, lesser the delay inside the system. So then we can compare these transit system as well. So that is the thinking behind this framework.
What my point is, for example, if you take BRT, you can imagine and expect maximum operating speed of maybe 25, 27 or 30 kilometer per hour,
Yeah,
whereas
yeah,
MRT
25.
begins with 30 or 40 kilometer per hour. So even that means the question arises, what is the benchmark value of desired travel time you consider? So is it different for BRT and MRT or it is the same for BRT and MRT? Or
Okay, okay, got it. So this index that actually uses this journey travel time that is taken in actual and journey travel time that is desired for a passenger. So when we ask from the survey, so this is the actual journey time that it takes, and the desire obviously it will be less than this actual, they say. But in case of this MRT and suburban rail, most of the time it comes around similar. There is no much difference actually. So then it is different for the different transit system, and it is based on this persons that they are saying. And so then we are taking this uh, uh, geometric mean of, sorry, this is like a geometric mean of all these respondents that they have responded, the ratio kind of, so
no,
how
that
much.
is what I am thinking. Somebody traveling by BRT should not expect the travel time of MRT. That's what I am expecting. That means, don't you think it would be prudent to pick some benchmark values that because everything is based on perception, but there are system limitations that at what operating speed a particular category of system can operate. So
Okay,
with reference to benchmark value, what is the desired and what is the actual, that may give
okay,
a more kind of realistic picture. And
okay, I got it. You mean to say that relative, we need to take the relative unit
that's
travel time.
because otherwise, somebody may tell any desired time. Even if he's traveling by BRT or city bus, he may expect it should have operating speed of 40, 50 kilometer per hour. It is never possible considering the
Yes, yes.
constraint of the system itself. In that case, what may happen that it may be more rational to compare BRT of one city or BRT operating on one corridor versus other corridor rather than the MRT, because from catchment area point of view also these systems are supposed to be non-competing with each other. They are
Yes, yes.
generally, complementary with each other. So from that point of view also, comparing one type of system, semi-rapid system with the rapid system, I don't know what conclusions we should be able to draw, and how far we should be able to work on those conclusions. That's my opinion. But you know better.
No,
You
no,
have
I think, yeah, yeah, you have said it right in that sense. Uh, okay, so in that sense, if you are not taking this, their travel, this speed of this particular system, speed limit, then this may not be like related. I mean, cannot be compared. Yeah, I think we need to think in this direction then. Okay.
Thank you. Thank you.
Okay. Anything?
Yes, there's a question in the chat box from
Uh-huh.
Sanjay RJ sir. Good evening. First of all, overall a nice presentation. Thanks. My question is whether all indicators weighted equally in KTPAI or does each have proportional significance? How sensitive is the total score to changes in perceived travel time reliability or affordability?
Okay, that sensitivity actually. Okay. So that we have done it, but I have not included in this presentation. So we have actually used this Monte Carlo simulation. So by checking if a unit change has happened in say like main travel time expected, then how much change, how much proportion of change will affect in this final score. So that I have done it actually, but I have not included here in this. That we can do. Is it the same thing that they asking?
Yeah, I mean, how sensitive this total score? That is what I think
Mhm.
is asking. Yeah.
Okay, sensitive. That is the thing actually. I have not added in this literature. Sorry, in this presentation actually, but yeah, that is done by using this. Like the general thinking is like if we can change this unit change in any of the indicator parameter, and then how much unit change, like how much changes in terms of percentage can happen in the final aggregated score. So then I think I don't remember even like we have done it, but if we can allow, I can check somewhere. I think in my uh, okay, what here? This is what they are saying. I think this is a sensitivity. So for CBT, the ND is network density. network density is found to be highly sensitive, wherein this BRT noise emission index is found to be highly sensitive. So likewise, we have done this sensitivity analysis. So this is the final CBT score, and there are like 10,000 simulations has been done by varying 10% in each indicator. So and how it impacts to this total score, that is CAT-P score. So by doing so, then we have got it like which are the highly sensitive and least sensitive indicators. So that I have done, but I have not added in the presentation actually. So
Yeah, okay, fine.
so I think
Thank you, sir. Now I request Srimati Ardra S. Krishna, Junior Scientist, to propose the vote of thanks.
Good afternoon, everyone. It is my privilege to propose the vote of thanks for today's technical talk on performance evaluation of public transport systems, the ongoing approaches and way forward. On behalf of NATPAC, I extend our heartfelt gratitude to Dr. Vishwajeet Kishore Verma for delivering such an informative and engaging session. The presentation covered important aspects including existing global and Indian approaches for transit performance evaluation, their shortfalls and contextual suitability, the introduction of a novel performance evaluation framework called CAI-TPEI, which assesses the overall performance of any transit system, which was illustrated through a practical case study. We truly appreciate the time and effort you invested in preparing and delivering such an insightful and engaging talk. The interactive discussions has enriched our learning experience and provided us with valuable insights. A special thanks to our director, Professor K.P. Sudhir, for his constant guidance and support. I would also like to sincerely thank all the participants for their active engagement throughout the session. A special appreciation to Professor Gaurang Joshi, sir, from SVNIT, for his valuable presence and contributions. Finally, a big thanks to the entire NATPAC team for their efforts behind the scenes in planning and organizing this session so smoothly. Once again, thank you all for making this event a resounding success. We look forward to hosting more such enlightening sessions in the future. Thank you and have a wonderful day.
yeah, thank you so much for attending, and thank you NATPAC for having me as a speaker here.
Thank you.